We've all got brains, so we're built for mathematics. So turn yours on and get ready for...
Mic Drop Math!
Yep, you heard it. We are still saying math, just like people in Australia, the United Kingdom, and most other English-speaking countries. Math or maths, both are correct. I'm Mrs. Wells Corfield, and even though my 5th graders and I live in the United States, we prefer to say math because mathematics is a world of intrigue and curiosity. Math includes computation, but it's also so much more. No matter how you shorten mathematics, we are thrilled that you are here for episode 2 as we explore order of operations. This is a controversial subject, one that many adults have had plenty of maths battles about. It even went viral on the internet just a few years ago, all over one little mathematical expression. People were getting 2 different answers and they weren't backing down defending their answers. At the end of this episode, I will give you the tiny expression that caused such a big controversy. You can decide which adults thinking you agree with, and if you think this was a necessary maths battle, or just adults making a big fuss about nothing. Your call. Before we can do that though, I need to get you inside our classroom. Now you can sit where you are right now in the back of the class and just listen in. Or you can follow along with the Mic Drop Maths Episode 2 handy dandy printout at home. You can find that follow along sheet on our website, micdropmaths.com. Pick what works best for you. Paper, no paper, either option is a good option. Now shh, class is in session. Okay, math class, I need 2 volunteers. Hands fly up in the air. Awesome! If you want to volunteer, you'll need to be willing to take off your shoes. A few hands go down. And you must be wearing socks. More hands go down. Okay. Eeny, meeny, miny, mo. Catch a mathematician by her toe. Mia and Ava, come on down. Now I've got their interest, right? We're sitting in math class and all they know is that for some reason some of us will be taking off our shoes. Mia goes to one corner and Ava goes to the other. I send a friend to each of them with a set of directions. The same directions, but not exactly. Both girls are asked to take off their shoes and socks and to sit in a chair. Here they go.
Stand up.
All right.
Put on your shoes.
All right. But that's kind of tricky standing up.
Gotta do as he says.
Put on your socks.
Wait, but I just put on my shoes. This looks ridiculous.
Tie your shoes.
But my socks are on.
You should see Ava. She has her socks over her shoes, and she's still trying to tie the laces, but can't because they're under her socks. All right, Mia, you're up next. You have the same directions as Ava, sort of. Let's see what happens.
Sit down.
Okay, I'm sitting.
Put on your socks.
Done.
Put on your shoes.
No problem.
Tie your shoes.
Hold on. Okay, all tied.
Stand up.
Ta-da!
Mia is now standing with her shoes all tied, and poor Ava is still standing dealing with her laces trapped under her socks. So what do you think, class? Are there times when order matters?
I mean, poor Ava almost fell down trying to put her shoes on, standing up, and now her socks are on the outside of her shoes. So yeah, I think order matters.
Can you think of any other time when order would matter?
Cooking.
Following a recipe.
Like running the bases in baseball.
Driving a car.
Can you think of any time in maths class where order would matter?
Can you give us an example?
Whoa, Nellie, let's take a step back. I think before we can talk about ordering any further, we need to put all of this into context. Putting something into context means providing a little extra information to help someone understand something better. Now, wouldn't that be nice? It always helps me to think of these expressions as stories. Have you ever read Two of Everything? It's a Chinese folktale by Lily Toy Hong. We can use her stories as inspiration to write our own expressions. Then, maybe we can decide which operations make sense to solve first. Once, long ago, in a humble hut, lived Mr. Hacktack and his wife, Mrs. Hacktack. They were old and very poor. What little they had came from their tiny garden. One day, the Hacktacks get very lucky and dig up a magical pot in their tiny garden. Spoiler alert! Whatever goes into that magical pot is going to get doubled. The first item that went into the pot was a coin purse with 5 gold coins. Can you write an expression to find out how many coins are in the pot? Remember, everything gets doubled. Math isn't about speed, so feel free to pause. Take your time and hit play whenever you've come up with an idea.
I wrote 5 plus 5 because I knew it was going to be doubled.
I wrote 5 times 2 since it was getting doubled.
I think you've both done excellent work. We could even draw a picture of that. I mean, really, we can draw a picture or representation of anything in math class. Let's keep that in mind as we move on. Let's play with that idea and step out of the book a little bit. What if Mrs. Hacktack already had a purse with 7 coins, but then she also had 4 purses that contained 10 coins? How many coins would she have? Can you picture that in your math brain? Let me say that again. If Mrs. Hacktack had 1 purse with 7 coins and she had 4 purses with 10 coins, how many coins would she have? I bet a picture in your mind or on paper would be really helpful here. We'll work on it while you do. Hit pause anytime. Okay, students, if Mrs. Hacktack had 1 purse with 7 coins and 4 purses with 10 coins, how many coins do you think she has?
I think she has 47 coins.
Huh, okay. How did you find that out?
She has 4 groups or stacks of 10. So I wrote 4 times 10, and then she has 7 more, so I added 7. I think I could use the expression 4 times 10 plus 7 to figure this out.
I think she has 47 coins, but I did it differently. I drew a picture of 7 coins and 4 piles of 10 coins. So I thought she had 47, but I wrote 7 plus 4 times 10. Would that work?
Did you both get 47?
Yes.
Well, Hudson, you wrote adding before multiplying because that's how you heard the story, but I saw you counted your piles of coins before you added the single set.
It was easier to count the groups first. I have a conjecture. I think we need to multiply before we add. But if it was all addition, we could add in any order, just like the commutative property of addition says.
You know what? I think you're onto something. You can write it Mina's way, 4 times 10 plus 7, or Hudson's way, 7 plus 4 times 10. But no matter how you write it, mathematicians agree, you should do the multiplication before addition. One way to look at multiplication is repeated addition, almost like a shortcut. It would make sense to find the product of those repeated equal groups before we added the rest. So do you think the order matters here the same way it did for the girls when they were trying to tie their shoes? When Mina solved the problem, she started with 4 purses and then added on the 7 extra. She wrote the expression as 4 times 10 plus 7. We know from counting the coins in Hudson's picture that the answer to this problem is 47. 4 times 10 is 40, and 40 plus 7 is 47. But did we have to multiply first in Mina's expression? She wrote 4 times 10 plus 7. What would happen if we skipped to adding 10 and 7 before we multiplied by 4? Well, 10 plus 7 is 17. 4 times 17 is 68, not 47. Whoa. We got a different answer when we added before we multiplied. From our little magical story, adding 10 and 7 before multiplying would mean we would add 7 coins into each of our purses. Mrs. Hacktack might wish that is how we did it, but it isn't. Sorry, Mrs. Hacktack. The order matters. I can hear your thoughts now. What about Hudson's way? He started with the 7 and then added on 4 groups of 10. He wrote it as 7 plus 4 times 10. What would happen if we added the 7 and 4 first? 7 plus 4 is 11. 11 times 10 is 110. 110 is certainly not 47. What went wrong this time? Well, 7 is a number of coins. 4 is the number of purses. What do you get when you add 7 coins and 4 purses? Nonsense, that's what. Instead, we start by finding the number of coins in the purses. 4 purses, 10 coins in each. The number of coins is 4 times 10, or 40. Add on your 7 extra. There you go, 47. Just like Mina. Either way, it's clear to hear. Order matters. Ooh-wee. Putting the order of operations into context has made my maths brain tired. I think it's time for a few maths laughs.
I had a hen who can count her own eggs. She was a chicken.
Why do plants hate math?
Why?
Because it gave them square roots.
What did the bee say when it solved the problem?
What?
I've got it.
Oh man, thanks for the math laughs, Mills, Sophia, and Trey. Now, mathematics is a beautiful language. The best way to learn that language is putting it into pictures. Can you write your own story expression? Send one to us on Twitter, Instagram, or Facebook at MicDropMaths, or simply log onto our website, micdropmaths.com, to share your story expression with us. We would love to hear from you and may even share a few of your story expressions on one of our future episodes. Okay, here we go. Let's dig deeper. My class is in 5th grade, so sometimes they see expressions that look like 30 minus 12 divided by 2 plus 4 times 3 minus 5. Whew. I'll say that again. And you can also see it on our especially helpful episode 2 follow-along sheet. 30 minus 12 divided by 2 plus 4 times 3 minus 5. It looks as long and crazy as it sounds. These problems can look intimidating at first, but once you get to know them, they're not so bad. Now, my students have never seen anything like this before, and I'm not telling them anything. I'm going to let them try to evaluate it on their own before we talk about it. You can try too. That's what the pause button is for. And we aren't worried about making mistakes. We celebrate mistakes. That's when our best learning happens. Since they know we learn more by making mistakes and trying than by waiting for answers to be handed out by me, the teacher, they immediately started scribbling numbers and operations all over their papers without any fear of being wrong. We learn by taking risks. Anyone want to share? Did you think of something equivalent to the expression 30 minus 12 divided by 2 plus 4 times 3 minus 5?
34. 4? 16?
31.
Okay, wow. 4 different solutions to the same problem. Now, I'll tell you, one of your answers is correct. Do you think I'm going to tell you which one it is? You're hilarious. This isn't the joke section of the podcast. You guys figure it out. All right. I'll give you a hint. Well, when I look at your work, all of you have accurately added, subtracted, multiplied, and divided. I wonder why you got different answers. Can you compare your papers and let me know what you find out?
Oh, I see. We all try to solve 30 minus 12 divided by 2 plus 4 multiplied by 3 minus 5, but we all did the operations in a different order.
Yikes. It sounds like Ava trying to put her shoes on all over again. This seems like a solid time for a history lesson. That's right. Here at Mic Drop Maths, we talk maths, but we also enjoy reading, history, and science. They're all meant to be learned together. What I'm about to share with you is not old maths. This little ditty that we like to teach in elementary school to remember how to solve these types of problems is less than 100 years old. In the maths world, that's actually really young maths. It happened about the same time that textbooks were invented and started to be used in schools. A Swiss-American mathematician named Florian Cajori was one of the first people to put some of these conventions in place. And even during his time, in the 1920s, there was still a lot of disagreement about what should come first, multiplication or division. So from now on, when you think about order of operations, try not to think of them as really old rules established by some really old dude a long time ago for some unknown reason. The rules are pretty young, but if you explore how the multiplication is related to addition and can be written equivalently, you'll start to see why operations are ordered as they are. All right, now that that's all said, I want you to listen closely, because what I'm about to discuss is a teaser hint about what went viral a few years ago. This little convention or rule is what got so many people so heated and the reason adults were fighting over how to simplify that expression. It's the exact same reason I'm very careful how I share this next idea. I want my students and all of you to know that math is about making sense, not memorizing. Math isn't a series of boring rules and procedures. It's beautiful and logical. So how I share the next idea is very important. Once you see how the operations are related to each other, you are able to solve expressions that have more than one operation. Always be willing to play with numbers and operations and look for their connections with one another. Feel free to question what you see. Why would I do this first? Could I do this instead? Scientists are always questioning. We mathematicians should be too. I find that drawing a representation or a picture, like how we did with the coins, always helps me know if I've made a solid math decision. Okay, so here it is. There are some mnemonic devices that can help you remember the order of operations. The most famous mnemonic device in the United States came around about the same time as textbooks, like we talked about earlier. But really, it's a memory tool, not a set of instructions. Tools aren't bad, but they also aren't everything. And when you use these tools, you need to know that they aren't math laws, and every tool has its limitations. The most common mnemonic device used in the United States to remember the order of operations is PEMDAS. PEMDAS. I'm sure if you studied order of operations, you've heard it. PEMDAS, aka, please excuse my dear Aunt Sally. Ring a bell? Each letter stands for an operation. P, parentheses. E, exponents. M, multiplication. D, division. A, addition. S, subtraction. Aunt Sally isn't bad. She's committed no crime. Shoot, we've been making excuses for her for years. If you live in Canada or New Zealand, go Kiwis, you might be using BEMDAS, BEMDAS, because you're using brackets instead of parentheses. If you live in the United Kingdom, Australia, Pakistan, India, or Bangladesh, you might be using BAMDAS, brackets, order, multiplication, division, addition, subtraction. Some countries even use BIMDAS. Look, the list goes on, so clearly we can't place this all on Aunt Sally. In our classroom, we use GEMDAS, GEMDAS. I spoke with some of my middle school friends, and what they said made sense. Kids were coming to middle school feeling really confident with PEMDAS, but the expressions didn't look the same in middle school. Really, they were groups, not just parentheses. When you first see the groups in middle school, they may look fancy and foreign, but so did the order of operations when you were in elementary school. All you need to do is take risks with the unfamiliar until you become familiar. That happens by asking a lot of questions and having a lot of discussions. It will all make sense in your own time. GEMDAS or PEMDAS tells us to simplify the groups. Then the exponents and roots, remember, they're a shortcut for multiplying and dividing. Then multiplication and division, because they're a shortcut for repeated addition and subtraction. And then the addition and subtraction because, well, they're all we've got left. Mathematicians have also decided that since multiplication and division are inverses of each other, we will do whichever one comes first when we're reading from left to right. The same thing goes for addition and subtraction. Solve for the one that comes first when going left to right. Remember those 4 students earlier? The ones who got 4 different answers for the same problem? Remember 30 minus 12 divided by 2 plus 4 times 3 minus 5? And I told them I wouldn't tell them who was correct. See, they all added, subtracted, multiplied, and divided correctly. They just did it all in a different order. That's a lot like what we were doing with Mrs. Hacktack's coins earlier. We could write the expression in different ways, but we had to do the operations in an order that made sense. If they would have used GEMDAS, they would have found out that the answer to that expression was 31. Let's try it with a different expression and see what happens.
Okay, 24 divided by 3 times 8 minus 4 plus 12 divided by 3. There are no groups or exponents and roots. Next up in the order of operations is multiplication and division. Division comes first, so I'm going to simplify 24 divided by 3.
Go ahead and write an equivalent expression now that you've started to simplify it.
Alright, now it is 8 times 8 minus 4 plus 12 divided by 3. Wait, so that's the equivalent to the first expression I saw?
It sure is, Nolan. What will you do now?
Well, using the order of operations, I need to deal with all the multiplication and division first. Next up is 8 times 8. Since I'm going left to right to choose whether I use multiplication or division.
You nailed it, Logan. So you've made another equivalent expression. What is it?
Now it's 64 minus 4 plus 12 divided by 3.
Correctamundo. What will you do now?
I know that I go left to right, but that's only when I'm choosing which inverse to do first. I've got to skip over the addition and subtraction for now to finish my shortcuts. So I'll do 12 divided by 3.
I can tell you're becoming familiar with this. What's your new equivalent expression?
I've got 64 minus 4 plus 4.
You're on fire! What will your next step be to simplify this expression?
Well, addition and subtraction are inversed, so I need to do whichever comes first. Going left to right, I'll simplify 64 minus 4, which is 60.
Oh, you were so close to evaluating this expression. What equivalent expression have you made?
This one is super simple. It's just 60 plus 4.
64!
There you have it. We simplified that expression down to 64. Just remember, when you're choosing between inverses, go left or right. Way to go, Nolan and Logan. You really know how to evaluate an expression.
Evaluate an expression? Say what?
It sounds like it's time to play the Mic Drop Math Game Show. Speak like a mathematician.
Contestant, are you ready?
Yes.
Okay, you have 5 seconds to hear a word, and then tell us what a mathematician would say. You can ask for examples. If you need a hint, good to go?
Yes.
Solve.
Evaluate.
Correct. Another way to say solve is to say evaluate. Are you ready?
Yes.
At least 2 numbers in one operation, but no equal sign.
Can I have a hint?
5 plus 7 times 6.
Expression.
Correct. No equal sign gives that one way every time. Are you ready?
Yes.
Making an expression as simple as possible without changing the value.
That's tricky. Hint, please?
5 plus 7 times 6 is the same as 47.
Simplify.
Correct. When you take a long expression and whittle it down to the basics, but you don't change the value of the expression, you've simplified it. Congratulations, contestant. You've done it. You've just won unlimited free episodes of Mic Drop Maths. You can get them anytime on Stitcher, Apple Podcasts, Spotify, our new website, www.micdropmaths.com. Great job!
This is awesome. I love podcasts, and I love speaking like a mathematician.
Congratulations, Tucker. Thanks for playing Speak Like a Mathematician. All this talk of expressions and GEMDAS reminds me of the time I saw GEMDAS try to line up for lunch. Here's a flashback of when it all happened.
Hey now, what seems to be the problem?
Well, I'm groups. I've been the line leader. I've been chosen by mathematics to go first, but they keep pushing and shoving.
Come on, guys. We all agreed groups would lead the way. Wait, are exponents and roots absent again?
Yeah.
I'll bet they'll have better attendance in middle school. Now, multiplication and division. What seems to be the problem?
Well, I'm division, and sometimes I should go first, but multiplication is always going ahead of me.
Is that true, multiplication?
Yes, but just look at GEMDAS. The M is before the D. He needs to just get over it.
Come on now, you're family. You're related, and you don't always go first. Division was sitting on the left today, so division gets to go before you.
Fine, but I'm still going before addition and subtraction.
Yes, that's fine, but you're only doing that to help them. You are a shortcut. If we line up before addition and subtraction, we'll all go to lunch faster.
That's not fair!
Come on, addition and subtraction. We're operations and we've got to work together. You're last, but you're still important. Lots of kids want to be the caboose. We need you too. You still have an important job to do.
Well, I'm addition, and I know I'm related to subtraction, and sometimes he'll get to go first. But today I was sitting on the left, so I should at least get to go before him.
I agree, subtraction. Can you get an order behind addition for today? If you were on the left next time, you can go before addition. Deal?
Okay, deal.
Flash forward back to the present. Whew! The life of a teacher getting her operations, or kids, lined up for lunch. It does help when we have an order, sometimes. So my class and I played with these groups in 4 operations for a while, and then one day, one of my students had a question.
Can there be more than one operation in the group? You know, the parentheses?
Conjectures were dropping like leaves in the fall.
I don't think you can have more than one operation inside the parentheses.
I think you can.
Okay, well, I love the talk, I can tell you. I've seen many groups that had more than one operation. So what do you think you do about that? More conjectures started flying around like baseballs at batting practice.
I think you need to do them as you see them. Go left to right.
I don't know. I think you'd probably still have to use the order of operations inside the parentheses.
Well, would you get the same answer either way?
No.
So then I can tell you, if you follow GEMDAS outside the parentheses, you should follow it inside of them too. If there are multiple operations inside the parentheses, you use the order of operations to solve inside the parentheses. All right, my mathematical friends, we have covered a lot. I think you're ready to hear it. The problem that went viral a few years ago was 8 divided by 2 times 2 plus 2. Seriously, that was it. 8 divided by 2, parentheses, 2 plus 2, close parentheses. Now, knowing what you know, what do you think? If you want to try for yourself before I reveal anything, hit pause now. Still listening? Some people felt very strongly that if you evaluate the expression, you would get 16. Other people felt just as strongly that you would get 1. What do you think? Could you draw a picture to prove it? Tell us what you think. We'd love to hear from you. You can follow us on Twitter, Instagram, or Facebook to share your ideas. You've definitely heard us say this before, but I'll go ahead and say it again. We're mathematicians and we love maths, but we also love books. Here are 2 books that we use to help us learn more about the order of operations.
In class, we read Two of Everything by Lily Toy Hong. My favorite part was when they found a brass pot and Mrs. Hacktack leaned over to kiss it and fell in. It was also hilarious when Mr. Hacktack looked over and there were 2 pairs of legs in the pot. It's a funny book and you can use it to write expressions. Pretty cool, you should check it out.
In class, we read Anno's Magic Seeds by Mitsumasa Anno. It's full of suspense. Disaster struck when a terrible hurricane came, and we didn't know what was going to happen to the family. It was also pretty funny. Jack tied his house to the tree. Seriously, this book is full of patterns, and the patterns change. You can write expressions to show the patterns and to find out how many seeds there are. If you like patterns and suspense, you should read this book.
Thanks for the book review, guys. Truly, there is no limit to what you can do.
I can explain the order of operations rules and why they are necessary.
I can simplify expressions using the order of operations and show each step.
I can describe which operation is completed first, which is second, etc. when given an expression involving more than one operation.
I can explain the order of operation rules and why they are necessary.
The kids at Mic Drop Maths would like to give a special shout out to Miss Moss's class at South Anna Elementary School. Thanks for listening to our first episode together as a class. We're glad you liked it. This podcast was brought to you by the words of Sarah Adams. Everyday love, changing everyday lives.